Hello everyone, we are back with another video. This is going to be on section 2.5 on infinite sets. If we remember, we talked about when we define infinite sets, an infinite set is a set that has a cardinality that is infinite. In other words, you cannot find the limit to the number of elements. So you can always find one more element in the set. So just remember that that is an infinite set. Now here we are not, they're not asking us to define infinite sets, or if they're not asking if these are infinite sets. They're telling us these are infinite sets and they want us to find a general term for the set. Use the variable n, where n is in the set 1, 2, 3, 4, and express your answers in simplest form. So n is in the set. N is in other words, n is an element of the set. So we can write that n is a natural number, because remember the natural numbers. We talked about n. Let me stop sharing here just to give you some background. The set of natural numbers is a set, and the set of natural numbers is an infinite set. So it starts with 1, 2, 3, 4, 5, and it continues. So this is an infinite set. You can always find a natural number bigger than the previous number. So the cardinality of the set is infinity. So the set of natural numbers is a set, and this is an infinite set, right? So this set, the set of natural numbers, is an infinite set because its cardinality is infinity or infinite. In other words, so I can denote the set of natural numbers by n, as we had in the past. And so we can write that the cardinality, remember the cardinality, we use the letter n to represent cardinality. We can say cardinality of n equals infinity, right? So that means that the cardinality of the set n is infinity, or the cardinality of the set of natural numbers is infinity. So here we're going to use little n to represent one of the elements there. So let n be a natural number. So this means that you can write n as 1, 2, 3, 4, 5, and it keeps going, right? All the way to infinity. Okay, now because n can be any of these numbers, we're going to use n. Now let me go back to the problems here. So here is the task that we have, and I will do like I normally do. We have 8 problems here, so I'll do the odd problems. So and then you guys can try the even problems. Remember that the answers are in the back. So whenever I don't do all of the problems, just remember that you can check the answers in the back of the workbook. And I choose not to do every problem because otherwise the videos will be super long, and then you need to have an opportunity to try some problems on your own as well, but you do have the answers in the back, so you can check your answer there. Okay, so let's see. So I'm going to write problem number 1. This is section 2.5. And I'm going to write the set, and then we'll work this one together. So we have 1, 8, 27. So this is sort of like what we did in the past, where we had to find the pattern, but now we have to use n, where n is one of those natural numbers. Remember, n is equal to 1, 2, 3, 4, 5, etc. So n is a natural number. So, but this is the, we want to focus on this set here. We're trying to find a pattern using n. Okay, so you can try, this is going to be, by the way, by trial and error. There's no clear-cut solution to how you should do these problems. All of these problems are going to require that we try different things. Like, for example, if we try to find a pattern here, you can see that we go from 1 to 8 to 27 to 64. Well, this one is, if you think of the prime numbers, you may be able to, if you immediately think of the prime numbers, you can see that you can get every number by taking a prime number. Well, one is not prime, but I mean, it doesn't matter if it doesn't work for the first element, as long as it works for all the other elements. So we can see something like 1, right, and then 8. Well, think about 1. Well, 1 is 1, right? But notice 8 and find the prime factors of 8, and you have like 2 times 4, 2 times 2, right? So this is going to be, you can write this one as 2 cubed, right? And then look at 27. Well, 2 doesn't work, but the next prime number is 3, so you can try 3 times 9, 3 times 3, right? And notice that it gives you also 3 cubed. You begin to see, okay, so you have, so here, and then you say, well, does it work with 1? Well, 1 is not prime, but I can still write 1 cubed, and that's going to give us 1 anyway, right? And so then you go to 64 and see if it works. 64, well, you're thinking, well, another prime, it's, and then here you ask, does prime work? A prime number, what is the next prime number? It's 5. Well, 5 wouldn't work here. So maybe the prime numbers don't work. Maybe, but hey, wait a minute. If I try 4, you can see that 4 times, I think 4 does work, because 4 times, let me see, 64 divided by 4. Yeah, 4 times 16, and then 4 times 4. Oh, wait a minute, 4 cubed, right? And then you can see that there's going to be a pattern here. So 1, 2, 3, 4. The next one, 125, can also be written as 5 times 25 and 5 times 5. So you see how that does work. So 5 cubed. Okay, now think about it. N, remember N is 1, 2, 3, 4, 5, right? So you can write that there is a way to write this with a general, you can write a general expression for this pattern using N as N cubed, right? Where N is 1, because, 1 cubed, 2 cubed, 3 cubed, 4 cubed, and so on. And so the expression would be N to the 3rd power for number 1. And again, you start with a hypothesis, you think that something might work, and then you realize that that didn't work, but this actually helps you to find the actual pattern. Okay? Okay, let us move on to the next problem. Let me share my screen. Okay, so you guys can work number 2. I'll try number 3. And let me write down this. Number 3 has, this one, it may be a little bit harder to find because the numbers don't seem to follow a clear-cut pattern. But again, we're going to look for ways. So it's 11, 23, 35, 47, 59. And let me stop sharing my screen here. Okay, so how can I, well, first of all, when you want to see what's going on between the numbers first, always try to see what's going on here. What is the difference between the first 2 numbers, for example? So 23 minus 11, you see that that's 12. And then see what is the difference between 35 minus 23, that's also 12. And then 47 minus 35, that's also 12. And then 59 minus 47. Well, okay, so we see now, why did I try this? Because I saw that there was no I mean, when I looked at the numbers 11, 23, 35, 47, and 59, they don't seem to have any common factors. So it's probably not going to be multiplication of prime numbers involved. But obviously the 12 has something here to do with this. So then the next question can be, how do I get 11? Well, I can get 11 by the first, how can I get 11 using 12? That should be the next question. So if I multiply 12 times 1 minus 1, that gives me 11, right? Then the next question is, how do I get 23 using 12? Well, what if I do 12 times 2 minus 1? That's 24 minus 1, that's 23. And can I get 35 using 12? Well, how about 12 times 3 minus 1, right? So that's 36 minus 1, that's 35. And can I get 47? Yeah, 12 times 4 minus 1 equals 48 minus 1 is 47. And then 12 times 5 minus 1, that's 60 minus 1 is 59. So you see the difference between the two numbers. And then you say, well, how do I get the first one using this 12 here, right? And then you see if you can write a general pattern. I noticed the 1, the 2, the 3, the 4, and the 5. That's n, right? Remember n is 1, 2, 3, 4, 5, so on. So then you say, well, how about 12n minus 1, right? That will give me the expression that I was looking for. Okay. So that is number 3 here. And you know, it may take you some time, so don't get discouraged if you don't see it right away. It's you know, you need to, it's trial and error with these problems. Okay, so let's move on to the next question. This was number 3. Okay, let's try number 5. And then we'll try 5 and then 7. So this is not a long section, not unlike, you know, most of the sections we have encountered. So 5, you have 1 over 1. And then 1 over 4. And then 1 over 9. 1 over 16. 1 over 25. Okay. And we want to see, obviously the 1 doesn't change. So I'm going to focus on the bottom here. And, you know, you want to stay focused on, because the 1s are not going to change, right? So the expression is going to have a 1 on top and then something with an n on the bottom. So 1, so n equals 1. But how do you get 4? Well, can you get 4? Remember, if I start at 1, then you have 1 square there. Now, if n is 2, can I get 4 with 2? Yeah, you can write 2 square. If n is 3, then how do you get 9? Well, you get 3 square. And if n is 4, how do you get 16? You get 4 square. If n is 5, how do you get 25? You write 5 square. So it looks like the expression is going to be n squared, right? Because this is the n, and then we are squaring n. We're squaring 1, we're squaring 2, we're squaring 3. So it looks like n is being squared. So then the expression will be 1 over n squared. Okay. All right. And let's see. Let's take a look at the last one. The ones that involve multiplication are usually easier. The ones that don't involve multiplication, that are a little bit harder. Like, look at number 7, for example. That one. Let me write it. It's negative 18, negative 29, negative 40, negative 51, negative 62, and then keeps going. We first have to see, like, what is the difference between each numbers here. So if you look at 18 and 29, negative 18 minus 29, so they're how many units apart? right? From negative 18 to negative 29, right? How many units apart is that? One way to realize is you can take 29, right? If you just make them positive, and then see where, well, 29 and 18, how far apart they are. And the same thing will be true for negative 18 and negative 29, right? So if you subtract 29 minus 18, you see that they're 11 units apart. So then these are going to be negative 11 units apart. So in other words, how many units apart are negative 29 and negative 18? The same as 18 and 29. So, but of course, this is we're in the negative, so I have to write negative 11. And you see that the same thing is true for negative 29 and negative 40, negative 11, and from here to here also, and then so on, okay? So they're negative 11 units apart. And then the next thing is, you want to ask yourselves, how do you write, just like we did in the past with one of the problems, how do you get negative 18, for example, with negative 11? How can I get negative 18 with negative 11 using n? So, well, I can write negative 11 times 1, because remember, the first n is 1. That's negative 11, and then I'm going to subtract. So negative 11 times 1 gives me negative 11. If I subtract 7 more, I get negative 18, right? Now, how do I get negative 29 using negative 11? If I write negative 11 times, and remember, you should be looking at n. So if I try negative 11 times 2, and I subtract 7 again, I'm going to get negative 11 times 2 is negative 22 minus 7 is negative 29, right? And then negative 11, so that's a 2. Negative 11 times 3 minus 7, that should give me the negative 40. And then you see the pattern, right? So the first two is, you need to get the first two, and then the first two work, then chances are the next will follow. So negative 11 times 4, that's a negative 44 minus 7. So that's going to give you a negative 51. And then negative 11 times 5 minus 7 will give you negative 62. So you can see now this is your n, right here. So then negative 11 and minus 7 will be the general expression. Okay. So that is question number 7. And so you can try the other ones, the other problems, to see if you're able to do those. And if you do have a question, just let me know. I hope this helps. So this was a short video. This is section 2.5. So that's it for this section. I hope you enjoy, and I hope you find this helpful. So I will see you on the next video. Okay. Blessings. Bye-bye.